Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Podcast listeners, Al Martin here. Welcome back. Thank you for listening as always. I do this every week. It's amazing. I'm sure you get tired of me. I get tired of me. But I keep learning, and I've kind of parlayed this into my learning time, and I always have an accountability partner because by the nature of a podcast. Speaking of the accountability partner today, I have a gentleman by the name of Ed Anuff, CPO of DataStax. Ed has 30 years of experience as a product and technology leader in companies like Google, Apigee, 6apart, Vignette, Epicenter, and Wired. I'm told that he is the founder of Enterprise, or was the founder of the enterprise portal leader Epicenter, which was ultimately acquired by Vignette. And in the 90s, piece of trivia, you launched one of the first internet search engines. I don't know what happened there. I don't know if it went sideways or whatever. You should be rich by now. You shouldn't be spending any time with me, my friend. You should be off in some island that you own.
Sure. I often think that. I think, unfortunately, probably one of the few internet search engine folks from the 90s that didn't immediately see the benefit from it. So, but it is true. Yes, the hotbot search engine back in the late 90s.
Well, did you monetize it at all, or it was?
So those were interesting days for search engines. They our main competition at the time was Alta Vista. So there was the early search engines like Excite, InfoSeek, and such. And then people figured out how to do, well, really what we would now think of big data or distributed data. And there were two approaches. And by the way, this will connect a little bit with what DataStax does today. So, there was, if you wanted to build, if you think about what a search engine is, it's a big database of content. And your approaches back then were either you built a bigger box, and so Digital Equipment decided they wanted to show off the fact that they had the largest server, and so they created Alta Vista. And this is ancient history for some folks, and so that was the largest search engine. And then I was at Wired magazine at the time. We decided that we would do a partnership with a startup out of Berkeley called Inktomi that was founded by Eric Brewer, who is a noted computer scientist and is over at Berkeley, is one of the Google fellows. But he started a company based on the idea that rather than having one giant server, that you could use a network of these servers and connect them together via high-speed connections, and you could distribute your data across multiple machines. And so as you had more and more data, you could just keep adding machines. And it was a very important insight. And what it allowed us to do was build what was the largest search engine at the time for anybody else. And we did moderately well. It was hard to monetize. So a lot of people think that, Google did many great things from a search technology standpoint, but probably the most important thing that they figured out how to do was how to monetize search, which is what made it a sustainable business. Because without that monetization, what you had was a very resource intensive business that was very hard to monetize through conventional advertising. You didn't necessarily put, big brand ads on search engines and so on. Keyword targeting hadn't really been invented yet. So we knew how to get the data there and to serve it at scale, but we didn't know how to monetize that. And that was a challenge. Ultimately, that technology became part of Yahoo, and they did quite well with it. And then, of course, Google took a similar approach towards distributed data, and the rest was history for Google. Along the way, that technology, the means by which you created this distributed data, worked its way into a bunch of research papers and white papers, which, through a long chain of events, ended up creating the Cassandra database, which is one of the most popular open source distributed databases and is the technology that DataStax is built upon. So there was a point of that whole story, which was that the early internet gave birth to this idea of distributed databases, which nowadays are still, not a household name, but anybody who's doing data at scale is using a distributed database.
All good. I gave us a little bit of your history because the first question I often ask, and I've already got part of it, is, your history. And look, I know we got the search engine in, but give us a little bit more about yourself in terms of your experience.
Oh, well, sure. So you mentioned in the enterprise space in the early 2000s, had a company called Epicentric that was really about letting companies, enterprises run their own portal web sites. And a lot of that technology is still in operation. It became part of a company called Vignette. Enterprise software never dies. There's lots of companies actually depending on that stuff, and it's pretty cool. But I definitely wanted to get more involved in doing stuff for developers and building platforms for developers. And so eventually found my way over to Apigee. Apigee was the company that made it possible for any business, for whether it was a startup or an enterprise, to make their APIs available out on the internet so that people could build applications against it. It became part of Google back in 2016, and again, still part of Google Cloud. Has been a very successful piece of it. And so those are the types of things that have been very interesting for me. Has been data at scale, and how do we build applications on top of that data.
I would presume the acquisition by Google, that's how you ended up at Google for a while?
Indeed, yes.
So are you a data guy, an AI guy, a governance guy, or is it just come back to data?
I am an infrastructure guy. I play a data guy on TV, and these days, I would say the convergence of those is AI. Right? Like AI is at this point in time, and this is where I've really started to get excited about it, has been that it is now at the point where it is feasible to build applications that are solving real world problems and that people are able to put into production.
So now you're the Chief Product Officer at DataStax, correct?
DataStax,
you have all development then, right?
Well, among other things, yeah. So DataStax is the company that brings the Cassandra database to the enterprise, to companies that are looking for a reliable partner to help support them use it. And one of the main use cases for Cassandra, with why people are accumulating this large amounts of data, is that they can use it in AI use cases. And particularly this year with generative AI, it's become a big part of how a lot of companies are ramping up for using their data for powering all of these next generation agents and co-pilots and chatbots and all of the all of the latest and greatest stuff that they're going to be rolling out on their websites.
And how long have you been at DataStax?
So about 4 years now.
They call you directly into CPO?
Yeah.
Did you start
Came in from Google and started as Chief Product Officer. We had a couple of folks that came over from Google at the same time. In many ways, it was sort of a little bit of an Apigee reunion.
So you're an infrastructure guy that is advertised as a data guy, and AI bridges both sides.
That's a good way of putting it.
All right. I was just trying to get... So let's talk about DataStax then. Yeah. What is DataStax? Let's just start very, very simple. It's supposed to be making data simple, although I'm told that we're not simple enough. So, maybe we'll go simple here. What is DataStax?
Well, so DataStax is built on top of Apache Cassandra. And Apache Cassandra is the open source database built on top of the technology of Google's Big Table. It was originally created at Facebook. The Apache Cassandra project spun out of Facebook. So this is a technology that people that are managing large data sets use. And it's an open source project, but in order to use it, if you want somebody who's supporting it for you, who runs it for you, makes it available in the cloud and all of that, that's what DataStax does. That's what we've built a pretty good business around. And as I said, a lot of this now is transitioning to how to use all of that data for AI purposes. But back to the part about making it easy. Well, the hard part about data, a lot of hard parts about data, but one of them ends up being that in order to do very interesting things with data, whether they're just powering your application or doing advanced things like AI, the power comes from the quantity of data that you're collecting and using. And as you start to collect that data, it becomes very hard to manage. And so you need a database that can handle that data at scale.
First of all, I'm a data guy, probably. I'm the opposite of you. I'm a data guy that bridges to infrastructure via AI. So we complement each other very well. So that leads me with a lot of questions. So I got it. Data or databases tend to be like a religion. Probably you know that more than anybody else because I'm involved with a lot of databases, or have been over
Yes.
time. But DataStax, we're talking a vector database, correct?
Yeah, we start off as we were one of the original NoSQL databases, and
Right.
we we have added the vector query, vector lookup capabilities to Cassandra, and so we are a vector database.
Why the vector database piece?
Gen AI use cases are driving a lot of new application development. And, as a database guy, you know that you don't just go and select a database for its own sake. As close to the technology is, you have an application, that's driving it. You have some form of workload. And depending on where you were historically, you may have had a bunch of business systems and you were looking at, your relational databases. And, that market has unified and migrated primarily on the open source front to Postgres. And for your sort of web tier stuff, you end up seeing a lot of NoSQL for a bunch of reasons. People were relatively set in terms of what they were using for what purposes. And then the decision points would be like, okay, do I have a huge amount of scale? Am I doing something web-based, maybe mobile-based, or am I doing something that's more of part of my business systems where I'm going to, look to more of a relational model and use Postgres or something of that sort. I'm going to go and look at something that is more. I'm going to look at something that's more dynamic. I'm going to look at a NoSQL database, and then you go and say, well, how much scale do I have? And if I have a huge amount of scale, I'm going to look at something like Cassandra or DynamoDB. If I don't have as much scale, I'm going to look at something like Mongo. These would tend to be the choices. Now, starting at the beginning of the year, people started to get very excited about the idea of doing, Gen AI, and particularly looking at what's called the RAG pattern or retrieval augmented generation, which is a fancy way of going and saying that before I go and generate an output, a response from my LLM, that I want to supplement the context that I put into the LLM. I want to take the prompts that the user has provided, the questions perhaps, but I want to supplement that with a whole bunch of information that I get out of my existing databases. Typically, I look that up via vector. It's a little bit more complicated than that because typically what ends up happening is you actually do multiple invocations of your LLM, so multiple inference stages. And as you do those, you pull additional information in. But the way that the model represents these, both at intermediate stages and even at the output stage, is it deals with things in the form of vectors, basically, semantic embeddings of the content in a multidimensional space, right? But it translates into a very large number, and you want to be able to look up rows in your database based on the similarity on the vector distance between what you're looking for and this set of vectors in your database. And it becomes a very important capability for retrieving the most relevant information that you can then feed into this LLM. And that demand has kind of upended the database business. And as a consequence, you see every database vendor responding to this. And, speaking for ourselves, more than half of the new customers and users and customers that we have signing up at this point are doing things that are vector related. So it isn't just the hype cycle. It's like, this is where the demand is. Now, one might debate how many of these things will still be in production 2 years from now. I honestly don't know. I can't predict the future. I think there's a lot of experimentation, but I think a number of these will go into production. So you are seeing a lot of I'm sure you're seeing this as you look at the database space, you're seeing a lot of realignment of the database industry around this use case. Because frankly, we haven't had a major new use case of such widespread adoption probably for about a decade. The last time we saw something like this was with mobile apps.
If you say that half of what you see in terms of the use cases are vector, do you just use DataStax in a NoSQL capacity then? Unstructured?
This is one of the things that's really interesting about vector databases, which is, to some degree, a vector database is just a database. So this might have been actually probably a better starting point.
Yeah.
But
That's all right.
that's good. We got there anyway. So what makes this vector database? We use the term. Lots of people are using the term, but it's a marketing term. What is a vector database? A vector database is a database that is able to have one or more columns being a vector data type, where those vectors are indexed, and you have some form of query semantics or query extensions that let you do queries based on vector distance. You may remember this from high school or college math, that if you've got two vectors, you can do a distance operation on them, right? And so with a vector, when you vectorize a piece of content, essentially the distance becomes how similar they are, right? So you've got a product catalog, and somebody comes in and searches for music. An album is going to be closer than a stereo, but a stereo will also be there, and those both might be closer than and maybe there's an iPod somewhere in there or whatever. I don't know if they still make iPods, but whatever, you get what I'm going. And so you know what I mean? So your distance becomes your sort order, and the closer something, and so you use a vector to query. You provide a vector, and you say, give me all the rows based on this column, indexed on vector type, based on the distance. And so that first result is the one that is based on this vector comparison, is the closest, sorted down. And what that means is it's often called vector similarity search, right? So what it means is that the results you get are the ones that are most similar. Again, what makes a database a vector database? I have a vector data type. I would put the requirement of saying it's a native data type, but not every database that's calling itself a vector database is actually doing it in a native way. It is a native data type for us, but that's because Cassandra has an extensible data type system, so we can add it, and it's as native as any other data type in the system. You have to have an indexing system and you have to have a query system. When you have those, that makes it a vector database. And so to some degree, this term vector database, very important from a marketing standpoint. I think when you go out, if we fast forward out a year or two, I think every database will have some form of vector capabilities. They just have to, because it's an important data type.
To that end, then, how is DataStax differentiated? I mean, even in the vector market, that you've got things like companies called Pinecone, Chroma, Weaviate, Milvus, I don't know, some of these other vector databases. Where's the DataStax niche?
Well, so the nice thing is we have a little piece of secret sauce, which is that we're the most scalable database that you can buy. That's a property of Cassandra, because it is, going back to its architecture, it is a fully distributed peer-to-peer database. And as your data set grows, you can just keep adding nodes. And we do that, and we're very good at that. And the proof points on that are, it's the database that Apple uses, the database that Netflix uses, the database that Federal Express uses, and a host of other companies. When you have a truly unbounded set of data, it's one of the only games in town. And even if you don't have a fully unbounded set, it's one of the best for serving your large data sets at scale. So when we go into the vector space, we bring all of those attributes. They don't go out the window. Our indexing system is flexible enough that we were actually able to add, vector data types as a native data type, and deal with the fact that, by the way, these vectors end up being very large objects. Most people who do an index don't do, a vector index is the equivalent of a full blob index that you don't break down into chunks. So it is essentially, think of it as having depending on the size of your vector, a 1500. Well, actually, technically speaking, it ends up actually being more than that, but it's because it's 1500 floating point values. So it becomes a large, very large numeric type that you do need to be able to go and do indexes and comparisons against. Most databases are not designed for that. And so what you have is a set of the companies you mentioned that did a very good job of making this possible for very, sort of small scale use cases. And they're very good if you're like doing a hackathon or an experiment. But they haven't really been battle tested. And so then you get into the question of all the databases you would reach for that have been battle tested, and you probably could create a short list. But the reality is we have a great one out there in the form of DB Engines, which listing of the most popular databases out there. And of those, Cassandra is the one that's proven the best at scale and performance at scale. And that's where we come from. And that's why we've a lot of large companies that are looking at switching to or moving to vector-based lookups in order to support these AI use cases are looking at DataStax and the Cassandra databases as the way to do it. Not to take anything away from the ones you mentioned. Like generally, you tend to, as much as we all want to use like the latest, greatest technology, most of the databases we use have been in some form of production use for at minimum of 10 years. And how long ago was it? The Postgres, was created by Stonebreaker and crew, like a while ago, right? 20, 25 years. Is that right?
Yeah,
probably. Yeah, something like that, right? So that's sort of the challenge of you don't necessarily want to be using the database that was just written last week.
I get the performance at scale, but isn't there a drawback in terms of data management and then querying capabilities compared to traditional databases?
So that's definitely a NoSQL versus SQL challenge. SQL has much richer query semantics. And there, by the way, I mean, just because we're a NoSQL company doesn't mean that I tell people they should never use a SQL database. There's always trade-offs. What I would say is that the NoSQL databases at this point in time, they're not like they were 5 years ago or 10 years ago in terms of being very bare bones. A lot of the query capabilities have improved. So there's a lot you can do. You do have the relationship challenge and everything that comes around that. You are definitely your data modeling around NoSQL. Your best practice is still around doing full denormalization. So there are trade-offs. There are going to be some schema designs that one should not take into a NoSQL approach. But at the moment, by the way, of all the ones you mentioned, really the primary relational vector database option that people have is PG Vector. And it's not a bad option, but the majority of the vector databases are some form of NoSQL and are non-relational in nature. Just by the nature of it, because a lot of these workloads don't tend to be relational heavy.
If you said earlier 50% of the time is vector, the rest, traditional NoSQL, if that makes sense. But does that mean that 50% of the time your DataStax is being used for AI use cases? New folks being signed up, new signups, yes. What I'm saying is of new customers coming to us, over 50% of the new people who sign up are looking to do something from a vector use case, yeah. But remember, by the way, apart from your vector column, there are other columns in your rows, and those are classic NoSQL, right? Like what I'm saying is the vector is a lookup for getting to a specific row, but then you've got a bunch of stuff in that row. Like you're not doing a lookup just to get the vector itself is just a way of finding the data. It's a little bit of a misnomer to say that just because it's a vector, like say, oh, it's vector versus NoSQL. Like the vector pieces are NoSQL too. And a lot of folks are adding that vector. For example, we have a lot of our existing customers are coming in saying, I already have this data set. Let me add that new column and let me add a bunch of vectors to it. Can you talk to a couple of the most common use cases that you're addressing on the AI side? So it again, most of these are some form of retrieval augmented generation or RAG, as it's called. So you'll hear a lot of the RAG pattern. People use that term RAG in a very expansive way. So sometimes what they're talking about is more advanced stuff, but typically what it simply means is that, well, let's give an example.
And this one, actually, we have one of our customers is doing. So it's a real world example. So they are creating basically a medical agent that doctors use, healthcare providers use to communicate with families and with as well as with the patients. And what they do is they want to go and translate sort of a correspondence or aftercare notes and stuff into a more fully built out patient care document. And so the LLM can generate that content, but in order to generate that content, you need context. And the context consists of user input. Those are what we call prompts, right? So you probably heard that term, like everybody who's used ChatGPT understands, okay, this is my prompt. Mm-hmm. When you use ChatGPT, you're actually using they're using a very powerful model, but the pattern that they use is actually very simple. They take the prompt, the question that you ask, they combine it with your history of your previous questions, and they throw that to the model. The model gives you a response that you see as the response, and ChatGPT tells you, yeah, go do this, this, and this. It takes that response, it puts it back into the history, and that history is just a set of rows in the database. And then the next time you add a question, they have they have that history. They take the history plus your new question, and that's how they're able to carry on a conversation. That's the quote unquote secret of how ChatGPT works, because these models themselves are completely stateless. The model itself has no memory. The memory of ChatGPT is a database. So now you've got a business use case. You've got that use case I talked about, healthcare. I'm not a doctor just having the conversation with the LLM. The LLM doesn't have all the answers. What I want to do is I want to have the input from the doctor, that's my prompt, but I also want to retrieve from the database, for example, an electronic medical record. And I want that combination to go into the LLM. The user only sees the prompt they type. They don't see that there's all this additional information. And that additional information is what the LLM considers when it generates the response. And that's how you create a personalized response. Now, again, that was a healthcare example. We have lots of folks doing this in retail. They have your order history. So you come in and, you say that you need a specific cable. You're looking for the cable. And again, the order history says that you just bought a computer. And so now the LLM isn't just sort of throwing you examples of recommending, these cables. It's able to actually go and say, maybe it's even asking an additional question, which is like, oh, is this for the computer you just bought? In which case, this is what you need, right? And so we see a lot of that. We've got a company called Priceline, one of the leaders in travel, that's using that for travel recommendations. It knows your travel history. That's coming in through again from the database. It knows all of the recent news. It knows that it's able to do a query of all of the places you've gone on vacations. It's able to see that you go to Maui every year, but it also is able to do a lookup of all the recent news, and maybe going to Maui this year is not a good idea. So when the LLM gives you a set of recommendations, again, they're based off of this personalized relevant information. So you see a lot of variants of this. And again, the broad term for this is retrieval augmented generation. And it's a very straightforward use case in terms of building these things out. It adds a ton of value, very effective in a range of customer support and customer engagement type scenarios. So I would say the majority of what we see from enterprises that we talk to is some variant of that. We are seeing other things too, but that one has been one that like everybody's been able to, latch onto and say, okay, yeah, that's something I should have on my website. I should have that in my mobile app. Actually, just saw a financial services firm, actually know several financial service firms on the consumer banking side that are building these into their mobile apps, so that again they can do things like that context that they can provide might be your spending history, and then they can go and have the LLM have more of a conversation about saying, oh, well, you seem to have been spending this stuff lately. Maybe you should think about this. And they can give you sort of more personal finance tips based on retrieving this context. So these are the types of things you see quite a bit.
So basically, if I could just repeat and oversimplify, I think you did it good, just in the last comment. But essentially, you could take data from like your EMRs, your electronic medical records, put them with an LMM, get a better answer so it's more personal in nature. And now you've got a personal LLM, if you will.
Yes. Yeah. And again, this is lots of variations on that. But yes, the idea is that most businesses are not using, they want the ChatGPT type experience, but it's not like this general purpose thing. They want you to be able to have a conversation with them about their services or products that is personalized based on what they know about you from past interactions.
So look, I have a few more questions for you, but
sure.
Before I move on, so in summary, if you would have the 2-minute pitch on why DataStax, what would that be?
Well, we're the company that makes it possible for you to put these things into production at scale. I mean, again, that's been DataStax's value prop for a while, which was that if you want to deliver these types of quote unquote digital experiences at scale, you need this type of database, and we're the company for that. So we have a great track record in this, and we carry that forward into AI.
Terrific. Thank you for that. Where do you think we're going?
Well,
give us some secrets. You look. By the way, you said you're not a data guy. You sound like a data guy to me. You're into data, my friend. I couldn't tell the difference.
Okay. Well, it's interesting. Of course, I get asked this question: where do I think we're going? And the short part is, the honest answer is I really have no idea. It changes incredibly quickly, like on a day-by-day basis. I think there's some things that are safe bets. So first of all, this year has been the year of experiments, but we are seeing, just like the stuff I was talking about from a business standpoint, we're seeing a lot of companies that are planning on putting this stuff into production. So I think you are going to remember most of the stuff, you see all these great experiments and all the blog posts and all of the company announcements and AWS investing in Anthropic or Google announcing this or all of these things. Most of that stuff is not in production yet, right? So the first piece is going to be, you're going to start seeing this stuff. It's going to become part of how you interact online, on mobile, and it's going to become a lot more ubiquitous. So, and as it does, it's going to snowball. This part is going to look a lot like mobile adoption, which is, you think back 10 years and all of us, and we'd see the mobile apps. And at first it was like, oh, that's cool. Oh, I just got an iPhone. I can play these games. And then, you go and see, oh, one of my competitors put out a mobile app. And then, and then your boss is saying, we need to have a mobile app too. And then pretty soon everybody has a mobile app. And now, like, everybody is interacting with, everybody's interacting with everything via mobile, and it all snowballs. So I think we will see a similar pattern, which is, even if you're not doing anything with this right now, somebody in your industry is, and it's going to catch fire, and suddenly you will find yourselves, if it's not already the big priority, it will be. I feel pretty comfortable on that. Having enough conversations with folks at, large companies, small companies, across the board, we're seeing that type of adoption cycle. I think that all sorts of stuff is happening from a model standpoint. New models every day, models you can run yourself. It won't all be cloud centric. That part is super interesting, and that part is probably the most unpredictable. The quality of the models, the size of the models. Other than to say it's going to change, it's going to upend everything, and these models are going to keep getting smarter, are safe bets. So even if you're looking at this thing and you're sort of laughing because you're like, oh, it's not that smart, I was able to stump it, or it hallucinated. That's point in time. That stuff is a point in time, and then beyond that, I would just go and say that I think we're going to see an explosion of stuff beyond. So the chat use case is going to be super important. And a lot of people are just very dismissive of it and like, oh, but people don't like chat. And that may or may not be true. But this technology, GenAI, it was more of an artifact of the user experience that people put up a chat box. And, talking about data, whether I'm a database guy or not, I did grow up in this industry, and there was a point in time, and in fact, this is still the case, that like, hey, the interface was a text box, but for plenty of other people, there was plenty of other front end tooling that sits between the user and the text box. So we will see all of this stuff from more of a visual interactive mode, and you'll see that happening very quickly.
You mentioned this won't be all cloud centric. Could you say a few words on that?
There's a very interesting thing going on right now with open source models, and it's now possible to run these models yourself. You can actually run them, on a desktop computer, and in fact, you can actually. I've seen some examples of being able to run it even on a mobile phone. So these are smaller scale models than, for example, something like GPT-4, but the quality of the models is fairly impressive, and they do things where they're they take a process called quantization, which is where they they take these values and they reduce them into a smaller range so that they can fit into smaller bytes in memory, and they find that they can still actually give very high quality responses. And so that's going to have a bunch of consequences, and the consequences are going to be, first, that for a lot of enterprises that have data that can't go to cloud, it will be possible to bring the AI to the data. And that's going to, that is going to unlock a lot more opportunities around this. And by the way, when I say that it's possible to bring this AI to the data, I mean on existing data center hardware. Like, you probably hear a lot about people needing GPUs and all of that. And obviously, NVIDIA is going to do really well for a long time to come. But it is going to be possible to run these models on the hardware you already have, and do so in a cost-effective way, and that's going to change a lot. And we already see a number of companies, particularly in financial services, where they just have too much of a security lift for taking this stuff to cloud, that are pretty far along with this stuff.
Note to self: stock in NVIDIA is not too late.
Yes.
Hey. So that's awesome. Thank you for that. Yeah, I think it's a hybrid world. I mean, I think we push everything to the edge and bring AI to the edge, et cetera. I also agree with you on the snowball. I think this is going to be a wild ride, because unlike before, with the advent of LLMs, transformers, we can get these models into production unlike never before.
Yeah.
I know here at IBM, we have so many freaking releases coming out. It is going to be crazy. I saw that ChatGPT just put out their voice.
Yes.
Now to correspond to their answers. So, I mean, I think it's, unlike before, I think, where there was, there's always hype, but I really feel, and I don't know how you feel about this. I wanted to ask this as we're wrapping up here, is if you're a client listening, you've got to pay attention and make sure you're taking action. Otherwise, you're going to get left behind, because it's going to move awfully fast. Do you think so? Or do you think, we got some time left, we're okay?
I mean, the truth is always a little bit in the middle. If you haven't started yet, you haven't missed the boat. I think the bigger question is, because there's always these hype cycles, and people are like, is this really going to happen? Look, I do enough conversations with folks, and I'm sure you do from your perspective as well. The use cases that I'm seeing, and first of all, the people, seeing this in serious enterprise use cases with situations that are going to add a whole bunch of value. Either they're going to drive a lot more customer engagement and drive a lot more revenue, or they're able to automate. They're able to use this stuff to automate a lot of their customer support, a lot of this type of thing that's going to actually save them a lot of money. So there's very real paths to value. The technology is at the point where, sure, it's non-trivial, but it has crossed the complexity threshold. It is at the point where you look at what people are building and you go and say, this is something I can succeed with. This is something that my existing developers can succeed with. So it feels a lot more to me. The most recent example is the mobile transition, right? And we look at that, at enterprise, we called the mobile transition, we called it digital transformation, right? Because mobile didn't sound like a big enough term, so businesses called it digital transformation. But the reality was digital transformation was mobile, full stop. Like if you actually looked at where the value came from, it was enterprises doing, interacting with customers through mobile. And that was a 10-year run, and it hasn't ended yet. I mean, I'm still talking to companies all the time that are like are just now starting their digital transformation journey. So I think the AI transformation is, it's starting. It's going to go for a while. It will favor people. Look, you don't want to be the bleeding edge, but you do want to be the leading edge.
Maybe that's where we should stop it.
Yes.
You don't want to be the bleeding edge, but you want to be the leading edge. I like that, Ed. Nicely done. This seems like that's your tagline. I like it. I'll tweet that today. Ed,
awesome.
Ed
Good.
Anuff. Look, is there anything that we didn't talk about that you're passionate about around?
I think we covered everything. This was a great conversation. I enjoyed it a lot. I mean, there's obviously more to talk about. That's the beautiful thing about this topic is one can go on forever.
Yeah. Well, I'm a data guy, as I mentioned. I could talk about this stuff forever, but eventually I got to be respectful of time. Hey, what do you do for fun, my friend?
Actually, as you might, well, since people are listening in, they won't see the video, but I do a lot of retro computer stuff. So I have an old Apple II back there, and a bunch of that sort of thing. Re-enjoying the glory days of the 8-bit computer world from the 80s.
What are you doing with an Apple II? Are you just like staring at it?
I actually fire it up. I play Ultima. I do all that stuff.
I was wondering. I was going to ask you about that. I can't see it very well. I thought maybe it was a typewriter. I said, "What?"
No. It is in fact an Apple II.
That's probably worth some money, I see some of the people selling these things now.
In not that much, but in nice condition. They're but no, just I'm sure you everybody I talked to at this point, all of us got our start back in the day with this stuff, right? And so it's a lot of fun to revisit it.
Yeah, although I pulled out the Atari the other day. It was been a while now. And I started playing those games, and I have to say they're nearly unplayable. I was expecting a lot more. My memory was a lot better.
And that part is true, but I agree. They often don't live up to the memory of it. But still,
Ed, I was playing the tank game, right? And so you got the tank on one side, you shoot it. I could not get out of I could see it coming. And I'm like, I got to get out. It wouldn't move. I'm like, I don't know how I used to play that. I had to predict where they were going to shoot. All right. Thank you for being here. Great conversation. Learned a lot. Appreciate it, man. Thanks, Ed.
Good stuff.
Thank you for listening. Hit us on almartintalksdata@gmail.com. I always like to hear from you. Until next time, we'll see you on the podcast.